Hello, this is question 4 from the MAT Specimen B paper that was released in 2009. We've got P and Q being the points with those coordinates. The mirror image of the point P in the x-axis is the point R with coordinates 7, -1. Mark the points P, Q and R on the grid provided opposite. Right, so P is at 7, 1, 2, 4, 6, 7, 1. So that is P. We've got Q at 11, 2, 8, 9, 10, 11, 2. That's Q. And then we got R is the reflection of P. So that is down there. Okay, so that wasn't a lot to get going, but still, I assume we're doing a lot of manipulation of these. Consider paths from P to Q, each of which consists of two straight line segments, PX and XQ, where X is a point on the X-axis. Find the length of the shortest path, giving clear reasoning for your answer. Right, okay, so if we want to go, well, this is why they're giving us a reflected point. So the path from, well, if we go a straight line from R to Q, then that is going to be the same. Let's draw this in. You may refer to the diagram. So let's draw that in as a straight line. And we can draw that down there, mark that as X, and then say that we've got the shortest length, so shortest distance from, well, in fact, we could say wherever X is. Yeah, let's start with that actually before I get into saying the shortest distance bit. I can say that the path PX XQ is equal to RX XQ, path length. Let's go with that. Therefore, shortest path PX XQ is same length as straight line RQ, and R is, so that's so we got a change of 4 in the X direction and 3 in the Y direction, so that's a 3, 4, 5 triangle. Okay, so that's fine. Sketch the line Y, Y equals X. Sketch the line L with equation Y equals X. Find the coordinates of S, the mirror image in the line L with a point Q. Right, so Y equals X, so I want to draw it through all of these corner points. That's not too bad. So that is L and Y equals X. And now I want to get the reflection of Q in that line. Okay, so we need to get the perpendicular. So perpendicular line to Y equals X and passing through Q. So we know it's got a gradient of -1. So that is going to be Y minus, 2 is minus X minus 11. So these intersect, these lines intersect when X minus 2 equals minus X plus 11. So X equals 13 over 2. That's also equal to Y, obviously, as well. So from, let's go now up here, from Q to L, we've got delta X is, so what have we gone from? We've gone from 11 to 6.5, so minus 4.5. And delta Y, we've gone from 2 to 6.5, so it's plus 4.5. So therefore, from L to S is the same, delta X, delta Y. Therefore, S is at, so we've got to take off 9 in the X direction and we've got to add on 9 in the Y direction. So 2, 11. So 2, 4, 6, 8, 10, 11. So S is up there. Okay, part 4. Consider paths from P to Q, each of which consists of 3 straight line segments, PY, YZ, and ZQ, where Y is on the x-axis, Z is on the line L. Find the shortest path. So we're now taking a different route from P to Q. I'm guessing, I'm going to want to have a new sheet to check this, but I'm guessing we're reflecting S. That seems what they're leading us to in order to do this. So S was up at 211, wasn't it, up there? That was S. So if we did this reflecting again, what am I going to end up with on all of this? So I was going to draw a picture of the whole thing, and then so draw in the y equals x, y, and then the reflection of that. So P was around about here, and then this is, what was P reflected to R? So that's P, that's R, and then Q was somewhere sort of here, wasn't it? And then we got S somewhere up here. Okay, so let's then mark in some, if I reflected S over to be, say, T, then let's see if I can match up all of these paths that we're going to be mapping out here, going from one to another. So say I had a route going from P to T directly, then that would be marking, what do they call them? That would be Y, and that would be Z. So if I went down to Y, that would go up to, well, it's not, oh, well, I'll call these Y, well, a Y is Y, I'll call Z Z prime, because it's not the actual Z, is it? This is the actual Z up here, and then off to Q. Okay, and then that would carry straight on up to S. So yeah, so that all works, right? So what I need to say then on all of this is that YZ is the length of YZ is equal to the length of YZ prime, and that the length of, what have we got, ZQ is equal to the length of ZS, which is equal to the length of Z prime to T. So that's all good. And therefore, the shortest path is PY, and then YZ, and then ZQ is equal in length to path, was it PT? Okay, and then PT is, we're starting at 7 and we're going to 2. So we've got delta X is 5, and then delta Y, we're starting at 1 and we're going to minus 11. So we've got 12. So we've got 13 there. We've got another Pythagorean triple there. So yeah, that's come out fine, isn't it? Yeah, just lots of reflecting around. Once we'd done it a couple of times, it was kind of clear why they'd got us to do S. Yeah, it all makes sense then, doesn't it? Yeah, that was quite a nice little question. I mean, a lot of the working out was fairly straightforward, but it was a nice one to think about. But it's got similarities with, as I say, doing ray diagrams in physics. So a lot of this sort of stuff you might have seen before.